Yes, okay, sir.
கேக்குதுங்களா?
கேக்குதுங்க சார். ஸ்டார்ட் பண்ணிடலாம் சார்.
Okay, ma'am.
Okay, sir.
Ma'am, give me 2 minutes. I'll
Okay,
just
sir.
arrange these PPTs and I'll share that
Okay,
entire
sir.
screen so that you can check and let me know.
Okay, okay, sir.
Yeah, fine.
Good afternoon to one and all present here. Now let us go for our session 9 of third day of our AICTE sponsored ATAL online faculty development program of artificial intelligence enabled sensors and networks for 5G wireless communication. Today's title for this session is artificial intelligence for IoT and wireless sensor networks. And today's resource person is Professor A.Manimaran, manager of VA Solutions, Bangalore. I request Professor S. Sweetline Sonia ma'am to introduce our today's resource person.
A very good afternoon, everyone. On behalf of Department of Electronics and Communication Engineering, Mahindra Engineering College, I am Sweetlin Sonia, Assistant Professor of Department of Electronics and Communication Engineering. Take this opportunity to welcome our resource person and all the participants to the session 9 of 5-day FTP on the topic AI for IoT and wireless sensor networks. I feel immense pleasure to introduce our resource person, Mr. A.Manimaran, a man of wisdom, to this session. Mr. A.Manimaran graduated as Electronics and Communication Engineer from Anna University, Chennai. Currently, he is designated as Manager in VI Solutions, Bangalore, and handling the major responsibility of supporting various industries in implementing several turnkey systems and system integration projects using NI products. He is also handling the major responsibility of improving the quality of engineering and science education and eradicating the impoverished methods of education and inculcating the interest for lab view. Sir has traveled far and wide throughout India and Sri Lanka, has delivered thought-provoking lectures which inspire the students and kindle their interest towards lab view, and have also visited more than 200 Indian engineering institutions. He has conducted more number of hands-on trainings to engineering students of various branches on LabVIEW basics and data acquisition. He has also conducted many faculty development workshops on various trending technologies, including RF communication and wireless systems, advanced signal processing and data acquisition and control, etc. He has delivered more than 350 lectures on experiential engineering education on varied technology topics. His areas of specialization include RF communication and wireless systems, measurement and automation, sensors, data acquisition, and signal conditioning, wireless sensor network, FPGA-based embedded system design. With this short note, now I would like to call upon our resource person, Mr. A.Manimaran, to take over the session. Sir.
Thank you, ma'am. Thanks for the wonderful introduction. Ma'am, let me just share my presentation on my entire screen. Please confirm whether my screen is visible to all.
Okay, sir.
Ma'am, I'm just shared my entire screen. I just opened my presentation. Hope this should be visible.
So it's visible, sir.
Okay, so just go through one by one. So slides are clearly right.
Yes, sir, it's clear.
Fine. The other PDFs also which I have for it.
Okay, sir. So everything
also
okay, sir.
visible there.
Sir, audio is also okay, sir.
Okay, great, ma'am. Great.
Okay, sir. So
Fine.
everything okay.
Let me just be clear to you all. So today's session will be on wireless sensor network and AI and 5G, so that we can use it, how good we can go ahead with this. I hope this will be fine, because we have another session also on 5G SDRs on Friday, I believe. Hello, Punlada ma'am.
Sir, yes, sir.
Uh, so, shall we start, ma'am?
Yes, sir, please.
Yeah, thank you. So, very good afternoon to everyone. I hope it's a very tough time to everyone. Post lunch session, immediately after lunch, sitting for 1 hour, 1.5 hour for a sessions of uh, a wireless mode or a wireless systems would be a vast subject. So I wish everyone to understand in a easier way. So my presentations are very simple. So we could see how things would be there in that. So I'll show you different things on how on 5G basis how NI offerings are there, what NI is supporting in the 5G network platform, how exactly we can make use of it. The other one is how for wireless sensor network, NI products will help us, how we can make use of it. So we'll just see these both the things very clearly. So I just split my session into two. One is for 5G part of SDR interaction. The other one is for WSM there. Hope it will be clear. So now we'll get into this 5G part. And before that, I'll just tell you who VA Solution, what we does. So we VA Solutions, we are alliance partners of National Instruments. We provide services, sales, trainings, workshops, and projects, research activities on majorly on NI products. So all we are there into our services team for the last 15, 16 years. We are there into team. So we provide LabVIEW trainings, LabVIEW workshops, LabVIEW project research activities. We do sell NI hardwares and softwares to majorly academics. So we our customers are IITs, IICs, NITs there, and what could I say? Other premier institutions also there in it. Many people would have heard of LabVIEW academies. So VA Solution is specially known for its services at VA Solutions, LabVIEW Academy services. So we made many colleges as LabVIEW academies. We provide supported to them after their LabVIEW Academy launch. So we helped many colleges to set up their LabVIEW academies. So we helped them to do some projects work for their students and faculties there. So we helped many PhD works over there. So these kind of activities what VA Solution does. So this all in the academic wing where we have as a dedicated industry wing as well. So where we do projects for DRDO, CMTI, HAL, so different defense related operations or here local companies or outsourcing of projects also we support through VA Solutions there. So this is a small introduction about VA Solutions. So many people would have heard of NI, so I don't want to give more information about NI. NI is a multinational company, so who majorly into automotive, defense, and energy, wireless RF technologies. They majorly into DAC devices. So they help you with the different softwares over there. We have Diadem, Test Stand, LabVIEW, and different options, multi-sim. So different softwares also they produce there. So now how exactly these elements are got into our academic part. So in majorly in academics, what they do it is through NI, wherever we go and where do we suggest is not only use the basic syllabus contents or syllabus training aids. Along with this, you please include lab related or any tool related programs or some animated kind of stuffs to teach some concepts. How do you can explain stuffs to students, how you can explain things to students. For example, when you want to show some sine wave, merely drawing on a screen or an overhead projector or showing some charts with the different parameters of it. So if we could show them about what is modulation schemes or how things would be moved out there, so that would help them more interesting way of understanding it. Some interactive way of learning would happen in the academic part. This is what we as solutions we are intended to do, and we are insisting every time in our sessions. So now, getting into this 5G part, it is a new term now, and most of the people are more crazy about this 5G because they are facing a lot of problems now. We are not getting proper network. We are not getting proper data speed. The coverage is less, though we have a signal, the coverage is less, the bandwidth occupied is very less, we don't have much elements to pay. 1.5 GB per day is not sufficient for us to work up with. So how we are going to sustain in the upcoming wireless technologies over there, how we are going to come up with this. So where this wireless sensor network or where this AI comes into picture, so all these parts it is. So for example, if you see in this, everybody knows that this 3GPP, who is a third generation partnership project, is the company or it's an organization. So who gives criterias or who gives a problem statement to this cellular networks or the cellular companies? They have to come up with some solutions. They will define the standards. So what would be the standard of this 4G? So there are many things over there in the network systems. So for example, if you see over here, there are wide variety of network we all would have seen there. For example, I could show this would be the right thing to showcase. So everybody, I don't know how many of you have used it. I'm sure most of us would have seen at least these type of 1G analog mobile phones or analog telephones in at least movies. So in all cinemas and movies, we would have seen this cellular, wide cellular phones there. So this is we would have seen, and this is the very first generation, and I'm sure everybody would have gone through or come up with this 2G network or a normal keypad mobiles. Still, it supports with that GPRS and edge support of internet connectivities. Later, we got this 3G there, so where we got a 3G network. Then now we are all in the smartphones, so where we all into 4G in it. So in a short term, if you see, these evolutions have happened a long back. Excuse me, these evolutions have happened long back. If you see, this is the roadmap of this evolution of this network, 1G network or 2G network. So where we have got it. But if you see, I don't think so. In India, we have got in 1998 itself the 3G network or the 4G network over there. See, very, I could say somewhere as in 2008 only where 3G got introduced or high-speed internet-based activities got introduced in India. So now if you see within this last 10 years, we got a very huge transition of 3G network to 4G network, and now we are all into 4G to 5G speed over there. So in between there is a 3.5G is there. So where there is only LTE is there, where we have Vivo LTE is there. So these different types of things are there where which will get you for high speed and data coverage or high bandwidth of data coverage over here. So here in this, when we get into this, why we need this 5G? What is the reason of 5G? Because when you have this 4G, when they say where we can go up a very high speed of data communication, when we get into it, what makes us to go to this 5G related work? Because when you get into this 5G related work, this will be the major problem here. For example, if you see in 2019 itself, by the last year, they are expecting an approximately 5.7 billion mobile phone users worldwide. So they will be getting it. And nowadays we don't want to say because all the academic classes from the kindergarten to the research level activities, everybody has their own dedicated smartphone to attend their classes there. So earlier, people who were trying to learn from home when they were there into foreign universities where they want to attend their classes over there. Now, if you see over there, all these PCs, everything have get into your hands now. So now everybody has a smartphone. Everybody has these smart gadgets. So everybody requires an internet in it, and we need to work for a very longer duration. We need to have a complete access to all our activities to be monitored, synchronized from your mobile phone to the smartwatch, from a smartwatch to your Google Drive, from your Google Drive to Google Photos to your laptops. So everything has to be synchronized wherever we need to work up with. So we all has to get in things there. So which means everybody is trying to reserve their own space in cloud. So now, if you see over there, your Google account has a 15 GB for your email account there. So which means everybody reserves some memory of your activities, what you try to do with them. So now how exactly we are going to access them, or how exactly we are going to make use of it. So when you want to go for a higher data access, or when you're going to go for a more number of people coming up with this, so there will be a lot of traffic. So how you are going to accommodate them within that particular bandwidth. So because 3G has a limited bandwidth, so 4G will have little more wider spectrum than 3G. So how we are going to accommodate them. Now people are more got 4G there. If we are 4 members in a family, minimum we have 5 phones over there in home. So how we are going to support that kind of internet facilities there? So how we are going to make use of it? So now people are more into the terms of automation, wireless support. So people are looking at if you see this left side, whatever we have, we need to have a smart home. So we need to have a smart car, a smart bicycle, or we need to have a smart street lights, or a industry 4.0. So industry 4.0 is a very big topic, but it falls under this 5G spectrum here. Because why the reason is, excuse me. So, excuse me. See, when we look for now I don't think so. Most of the people are facing this call drop problems, because now Indian networks, they have improved very much when compared to the last 5-6 years over there. Now this network is very good. So unless until at a very remote place of travel, you will face this problem. Apart from that, we have a very good coverage now in this 4G over here, because earlier whenever we are traveling in a bus or a train, whenever there is a rain, we will not get a proper signal over there. Now people who are travels also, they can continuously can use their mobile phones throughout their travel without any issues of the network or a call. So now if you see over there, when I use my smart home, when I'm there in a ground floor, or in my living room, or in my first floor, or in my office, in my home office, I should be able to access this internet. So you need to have a device. When you go to 5G there, then you need to have something as a small cells, which you need to have, which to be present in everyone's home. It is something earlier what we are trying to do, almost we are doing it in all smaller related RF related reception parts, which we are doing it. For a simple example, earlier we used to have one common internet provider will give us an internet connection there. He used to set up a small antenna. Before that, what we used to have it is, we used to have a DTH only to our home. So earlier it was a dish, and previous to that we have a dedicated antenna where we could use it for our home only for Doordarshan purpose. So somebody will transmit from the base station. We used to receive the signals and we'll be watching programs over there in a TV there. The similar way now also we have it as a common base station transponders are there. So where we are trying to receive signals through our mobile phones, which are doing it. Now, when we get into this 5G part has a lot of elements in it where we have multiple repeaters are required for it. We used to call it as a small cell. It is something as every particular distance or every particular elements we need to go for, because 5G uses a millimeter waves which are very sensitive to rain or diffractions. It cannot pass through a building, it cannot get in there. So now what we will be doing is, if you have a mobile connection over there in your home, then you will be installing a small cell in your home. So this is how we will be doing it. So wherever we go, so this internet service provider company has to insert some small cell in your bus stop or in your public places as a theater, or when you go into the your smart street lights, or you get into your offices, or you get into your industry, you need to have it, because now you need to check the what is the production level happening from your office. The same thing you want to monitor from your home also when you want to work from home. So now if you see that everything has to be get connected and work over there. And if you do program of your car from your starting point to destinations, it will automatically takes you over there. Now these uberless cars are there into many countries. They are all started using it. So only thing is, we are taking more time in regulating things. We are taking more time to develop our infrastructures over there, because when we want to go for a driverless car, our infrastructure should be good. So the road should be clear, the signal should be proper, and there should not be a sudden traffic occurs. So these many things we supposed to do there. So how we are going to monitor that part, we will do it. So now to get into this 5G, I'll just play a small video so that you'll understand how to go further with this 5G or why we need this 5G. A small video. This is available in YouTube as well. Uh,
It's no secret. Today's 4G LTE wireless networks simply can't handle the data demands of a rapidly approaching, hyper-connected future. Phones, homes, and offices, planes, trains, and automobiles, all connected all the time.
A real drive in the race is because we're just running out of bandwidth in 4G. Customers are demanding more and the operators are struggling to be able to deliver it. I think whoever gets there first is going to open up huge societal and economical benefits.
On the leading edge of millimeter wave technologies, wireless researchers at Nokia were able to develop the world's first millimeter wave communication link capable of streaming data at speeds exceeding 10 gigabits per second.
so do you see over there, they are planning for a 10 gigabits per second, which was the very first NA, and Nokia have used it.
Every industry will be using 5G, and especially we are seeing the huge applications of Internet of Things, starting from e-health, e-commerce, automation, manufacturing, agriculture, car industries. The industry has already adapted to this view that 5G is about connecting people.
5G is one of the biggest enablers for technology for probably the next decade, because it enables so many different things. It enables drones, it enables self-driving cars. It makes mobile even better and faster.
One of the biggest, earliest challenges was understanding the radio channel, being able to model the impulse response, because you first have to understand the channel to do anything. So the channel is really pretty well understood now. So now, using the channel, you have to figure out what's the best, most efficient, power-efficient way to build these multi-gigabit per second data rate channels, to build the air interface. And do you use MIMO, massive MIMO? Do you use beam steering, where you build the antennas to create very narrow beams? And how do you build those antennas? Because that's a huge challenge. Right now, there are a lot of antennas in your cell phone, but they're all pretty large and there's relatively few of them, few in number. Well, now we're going to go to where there's dozens or even hundreds of antennas for millimeter wave.
In the race to 5G and the need to address anywhere, anytime access, two leading technologies have emerged: massive MIMO and millimeter wave. Both promise significant gains in wireless data rates and link reliability, and both have yielded some truly impressive results already. In fact, in a collaboration between Bristol and Lund universities, wireless researchers are setting a few new world records in spectral efficiency while prototyping new approaches to 5G wireless using massive MIMO technologies.
Many people really worry about how their mobile device is connected to the network. What they wanted to do is work, and massive MIMO will make it work exceedingly fast.
Creating a chip right now with the shrinking kind of dimensions is truly expensive, and you got to do it right the first time.
The Third Generation Partnership Project, or 3GPP, has begun working to create global standards and specifications to tackle this data rate issue.
The 3GPP is vitally important because it's the group that determines standards. And without standards, things aren't going to work together. And if things don't work together, something that I build in the US is not going to work in China, is not going to work in Europe, and vice versa.
For those of us as old as I am who remember the days without standards, in the United States, there was TDMA, there was CDMA, there was AMPS, which is the old analog, and GSM. So there were actually 4 different standards at one time in the United States. And then if you were with Sprint and you wanted to transition to AT&T, you couldn't do it. You were basically locked into that service provider. And then to transition, not only you have contract issues, but you have to change your phone because the technology was completely incompatible. And you don't have that situation today. Most vendors, service operators across the globe allow you to interchange freely. And that's what standardization gives you.
At NI in recent years, we've been hard at work investing in 5G research, prototyping and testing, and collaborating with top researchers from around the world to build rapid new approaches to solve system issues and pave the path toward widespread deployment.
I think what started a lot of the wireless research was this vision of a 5G connected world. And with that vision, it spurs innovation from researchers all over. And so things like, being able to not just have an idea, but be able to prototype that. And that's really critically important because that prototyping step means that that idea actually works in a real world, in a real setting, under real conditions. And that's kind of the proof point where it can be included into the standards. On the industry side, if they have a particular idea that makes it into the standards, they'll be the first, hopefully, to have products that conform to that idea into the standard, and they have an economic or financial benefit to that.
We were looking for partners to implement this Nokia's vision. We wanted to be ahead of the industry, and we were looking for a quick prototyping platform. So we looked at all the players and thought AI's platform gave us the right perspective where we can implement our vision.
It means offering the peace of mind that comes with not needing to rely on a single vendor for all your needs, thanks to NI's open and extensible platform. It means innovation at all phases and stages of your 5G wireless journey.
We have been working with some of these leading vendors who has truly embraced a new paradigm in doing research for 5G, which is using off-the-shelf common platforms, which Unite creates, right, to further their research, to really go at it really, really quickly. And they've reaped the benefits. They also understand that it's important to be at the forefront, and some of them are embracing a more open approach to actually using off-the-shelf platforms like ours as well to prototype the next generation ideas to kind of lower the risk overall.
NI offers a platform approach. It's both hardware and software. And so when researchers have an idea, they typically model that idea in software. And so now the hard part is going to the hardware. And so different companies make hardware, different companies make software. We have both. And in fact, that combination of hardware and software enables a researcher to be a wireless expert, not necessarily a hardware expert or a software expert. So they can focus on their domain expertise and take their idea and prove it in a real world setting faster and easier than other approaches.
I think 10 years from now, we're going to look back and say that 5G was one of the most important pieces of technology that ever came out. It enables everything that we see today that's emerging, whether it's self-driving cars that talk to each other so they don't run into each other, to having the most amazing video experience on your mobile device, on your computer, on your tablet, and on your TV. It's going to be incredible. And I really think we're going to look back on this and be amazed.
Now is the time to unlock the next great technological revolution in telecommunications. And with NI's help, it's your turn to be on the cutting edge of making it happen.
So here, this is from the NI there, and there is another one where we could understand 5G from the conceptual based from the IEEE spectrum. So how they are standardizing it, how it is being used of.
Every new generation of wireless networks delivers faster speeds and more functionality to our smartphones. 1G brought us the very first cell phones, 2G let us text for the first time, 3G brought us online, and 4G delivered the speeds that we enjoy today. But as more users come online, 4G networks have just about reached the limit of what they're capable of at a time when users want even more data for their smartphones and devices. Now we're headed toward 5G, the next generation of wireless. It will be able to handle 1,000 times more traffic than today's networks, and it'll be up to 10 times faster than 4G LTE. Just imagine downloading an HD movie in under a second, and then let your imagination run wild. 5G will be the foundation for virtual reality, autonomous driving, the Internet of Things, and stuff we can't even yet imagine. But what exactly is a 5G network? The truth is, experts can't tell us what 5G actually is because they don't even know yet. But right now, there are 5 brand new technologies emerging as the foundation of 5G. Millimeter waves, small cells, massive MIMO, beamforming, and full duplex. First up, technology number 1, millimeter waves. Your smartphone and other electronic devices in your home use very specific frequencies on the radio frequency spectrum, typically those under 6 gigahertz. But these frequencies are starting to get more crowded. Carriers can only squeeze so many bits of data on the same amount of radio frequency spectrum. As more devices come online, we're going to start to see slower service and more dropped connections. The solution is to open up some new real estate. The researchers are experimenting with broadcasting on shorter millimeter waves, those that fall between 30 and 300 gigahertz. This section of spectrum has never been used before for mobile devices, and opening it up means more bandwidth for everyone. But there is a catch. Millimeter waves can't travel well through buildings or other obstacles, and they tend to be absorbed by plants and rain. To get around this problem, we'll need technology number 2, small cell networks. Today's wireless networks rely on large, high-powered cell towers to broadcast their signals over long distances. But remember, higher frequency millimeter waves have a harder time traveling through obstacles, which means if you move behind one, you lose your signal. Small cell networks would solve that problem, using thousands of low-power mini base stations. These base stations would be much closer together than traditional towers, forming a sort of relay team to transmit signals around obstacles. This would be especially useful in cities. As the user moved behind an obstacle, his smartphone would automatically switch to a new base station in better range of his device, allowing him to keep his connection. Next up, technology number 3, massive MIMO. MIMO stands for multiple input, multiple output. Today's 4G base stations have about a dozen ports for antennas that handle all cellular traffic, but massive MIMO base stations can support about 100 ports. This could increase the capacity of today's networks by a factor of 22 or more. Of course, massive MIMO comes with its own complications. Today's cellular antennas broadcast information in every direction at once, and all of those crossing signals can cause serious interference. Which brings us to technology number 4, beamforming. Beamforming is like a traffic signaling system for cellular signals. Instead of broadcasting in every direction, it would allow a base station to send a focused stream of data to a specific user. This precision prevents interference and it's way more efficient. That means stations could handle more incoming and outgoing data streams at once. Here's how it works. Say you're in a cluster of buildings and you're trying to make a phone call. Your signal is ricocheting off of surrounding buildings and crisscrossing with other signals from users in the area. A massive MIMO base station receives all of these signals and keeps track of the timing and the direction of their arrival. It then uses signal processing algorithms to triangulate exactly where each signal is coming from and plots the best transmission route back through the air to each phone. Sometimes it'll even bounce individual packets of data in different directions, off of buildings or other objects to keep signals from interfering with each other. The result is a coherent data stream sent only to you. Which brings us to technology number 5, full duplex. If you've ever used a walkie-talkie, you know that in order to communicate, you have to take turns talking and listening. That's kind of a drag. Today's cellular base stations have that exact same holdup. A basic antenna can only do one job at a time, either transmit or receive. This is because of a principle called reciprocity, which is the tendency for radio waves to travel both forward and backward along the same frequency. To understand this, it helps to think of a wave like a train loaded up with data. The frequency it's traveling on is like the train track. And if there's a second train trying to go in the opposite direction on the same track, you're going to get some interference. Up until now, the solution has been to have the trains take turns or to put all the trains on different tracks or frequencies. But you can make things a lot more efficient by working around reciprocity. Researchers have used silicon transistors to create high-speed switches that halt the backward roll of these waves. It's kind of like a signaling system that can momentarily reroute two trains so that they can get past each other. That means there's a lot more getting done on each track a whole lot faster. We're still working out many of the kinks with millimeter waves, small cell networks, massive MIMO, beamforming, and full duplex. In fact, all of 5G is still a work in progress. It will likely include other new technologies too, and making all of these systems work together will be a whole other challenge. But if experts can figure that out, ultra-fast 5G service could arrive in the next 5 years.
So now, if you see there, this 2 videos would give you an idea about what is 5G is, how NA is into with the different company collaborations. They are working out for the real-time implementations of 5G here. So now, if you see here, every country has their own standards of spectrums to work out with. So here, why actually we need to go for 5G, or how or what exactly 5G offers. See, 5G, what it does is it reduces the latency in delivering a contents over there. For example, the data packets delivered between base station or a call connecting will be very, very less than 1 millisecond. So which means whatever the time now we have, which will be 10 times lesser than that. So now if you say connection density, they are feeling more people will get connected there. So now everybody will have minimum 3 to 4 gadgets. So they will have a mobile phone, they'll have a laptop, they'll have an iPod, they'll have a smartwatch. All 4 has to be connected with an internet, and all 4 has to be synchronized each other. And in whichever you want to see the information, you can take it over there. So everybody will be on the IoT form. So now if you started using all the 4 items at a time, obviously you'll be consuming more spectrum, you'll be consuming more amount of data. So your data has to be more faster when compared to earlier. So that's why you need to have high throughput, which is 10 times higher than that. And the spectrum efficiency, they are increasing in gigabits over there, so that it will reach many places and it will work very strong. So to avoid traffic capacities, they are implementing with small cells. As I was mentioning, now later stages, if you are trying to buy a connection, so now what you will be doing is you will be buying a small cell connection also there. So how you set up a DTH antenna to your home. Similarly, you will be setting up a small cell connection also to be your home there. As how we all have this internet connection or router box in our home. The same way we'll be doing for our mobile connection also, so that it will have a better connectivity. And this network efficiency, obviously they will be optimizing it so that we'll be using for in a better way there. So now whatever we have seen is we have seen what 5G gives when we go for it. Obviously what 5G required also we need to see, because making things ready for 5G won't be that easy there. Because now, when I don't know how many people would have faced this problem, even now they are facing this problem. So when you have your 4000 mAh mobile, earlier when you have only 2000 mAh mobile, so when you go with now, how much mAh you have your phone battery, it won't be sufficient for you. Because earlier when you have this 1500 mAh, it lasts for a day. Later, from you switched from 2G to 3G, when your data is on, then your battery went like anything. So your battery will drain at a very fast rate because it is accessing data, it will dissipate heat. So whenever your data is on, your mobile will heat more. So how we are going to control that? So we all switched to 2000 mAh, 3000 mAh, 4000 mAh. Now you have mobiles of 6000 mAh there. Now you have power banks of 20,000 mAh you have. So everybody is running out of batteries now. So because it won't be sufficient for us when we watch movies or when we play games or when we play YouTube videos, it won't be sufficient for us. So how we are going to use it? So when 4G is consuming this much power, think of when we get 5G over there, how much power it will take. So they are defining it. 5G network should have or should consume low energy so that the battery will last for a longer time, and the device densities will be more, so the 5G should accommodate multiple people there, and the cost of operation for 5G should be less. Now all mobile companies have increased their tariffs, so from this 1st December, so everybody will be aware of it. And so now if you see over there, when you are operating at a 5G at a very high speed, when we are looking into the videos, they were saying that when you are downloading a movie is there, which will download in few seconds. So which means think of a 1.4 GB movie, you can download maximum of 4 seconds to 5 seconds. Then think of the speed now. So now it will take minimum, very good connections, you will take minimum 20 minutes to 15 minutes of time you will take to download an entire movie. HD 720 pixel HD movie if you take, then think of in 5G it will get downloaded in the form of 2 minutes to 3 minutes there. So how we are going to do that? So then enhanced cellular footprint. So which means basically to avoid multiple cellular networks, or I could say it as multiple cellular devices, but that won't happen because there will be more number of mobile devices or gadgets will be get into it. So 5G has to cater these many elements. And when you come for this enhanced mobile broadband, so obviously there will be more number of people, there will be multiple devices will be there, so their data rates also to be increased, the capacity should be increased, or they should have along with that they should have a very high throughput so that the data transfer rate at which they are receiving signal will be very very high speed, and the information also they will get very clear. And we could say as a smaller difference, now when you open a video in your laptop or in your mobile phone, immediately when you open your mobile phone in your YouTube videos, it will not show you a pixel or a clarity or picture quality will not be clear to you immediately, because there will be a slight delay where it goes from 240 pixel to 360 or 360 to 480. It transfers, because based on your data connectivity, the signal will get adjusted and your quality of picture will move on, unless until you make it as a specific one. Always you want to stream only HD, it will take time to load and move on there. So when you get into this 5G, there won't be any loading. The same thing everybody have said when 4G has come over there, because at that time the input users of 4G mobile users are less. So now users are more. So obviously we need a high throughput. When 5G comes also, people will be more started using this 5G there, because this will take many devices to nook and corner of the world. So now this mission, so what it is, so the signal has to be reliable. It should not get disconnected often. It should not, the house or the wall or rain or a 3-floor building or a 4-floor building, corner house should not be a barrier for this mobile phone signal. Or a hall will get a signal, a bedroom will not get a signal over there. So this should not be a problem. Or the call connecting time, what it takes to get connected to a call should not be more time. So most of the times you would face a problem when there are multiple people are trying to reach in the network region and they are trying to make calls. We all aware of it. It will get connects to it based on the network time or network issue. Most of the times you would be face this in a BSNL network. So the network is busy, you will say, but people are available, but you can't make a call over there because the network is occupied. Or sometimes you will get this beep sounds. So there will be multiple beeps. Later the call will get connected to it. So it is all these latencies because you are waiting over there for the call there. You are as a user or you are a customer, you are waiting over there for your call to get connected there. So now these things should be reduced so that you will have a wider bandwidth so that you can easily get accommodated there. So now when you get into this 5G elements there, so these are different options there. This is what I was talking about. Most of the people will think that H is your 3G there. Even H plus is also comes under 3G. So what we used to call it as a 3G, 3.5G, 3.7, 3.9. So because if you see, most of the people will be talking about your mobile phones. LTE mobile phones are 4G network. No, LTE mobile phones are not 4G network phone. LTE mobiles or LTE advanced mobiles are the 4G network. LTE advanced or LTE advanced Pro, which means these are the mobiles where you will have this Vivo LTE options. So in LTEs, you will not have Vivo LTE. So in LTE mobiles, when you are using internet, your calls will not get connect. So when you have this, face this problem, multiple times you face this problem. So whenever your call will get disconnected, then only you will get your WhatsApp messages delivered. So these are all the practical problems where Indian peoples are faced, or I don't know how many people are still facing it. So we are still in the progressive line, because now your most of the things are getting into there. Very earlier there was a CDMA mobiles there. Now most of the companies, if you see over there, you all got this eSIM. So where you will not face any problem over there, your network will be strong and you will be getting everywhere, your coverage will be really good. So this is what it is. So now if you see there, obviously there are multiple questions will come in. So when we go for this 3G network to 4G network or 4G network to 5G network, you have to change your handsets or you have to change your devices there. Why the reason? That's why the reason everybody has 3 to 4 mobiles in our home now. So we all would have got a mobile phone which of 3G. Now once this network got updated, we want to make use of the facilities, so we are using it. So obviously the devices will not be of higher standard compatibility, whereas it will support the downgrade version there. So 4G mobiles will support for your 3G network as the same. The SIM card supports for your GPRS keypad mobiles as well. So if you see there, when you get into the latest part, so what NI gives there in it, NI completely into the testing of your 5G network on a physical layer part, on the making the standards, everything. NI is not into any mobile phone devices, nothing there. NI is totally into this industry where they develop this 5G, test it, whether they are reaching the proper throughput or not. So whether it is meeting the quality or meeting the standard or what. So for that purpose, we have our softwares, our hardware modules are available. So along with Nokia earlier, we have achieved 10 gigabits per second data transfer part, and we are the first pioneer in this RF massive MIMO part where we have successful 128 cross 128 massive MIMO test bed where we did and we succeeded with it. So if you see over there, the data transfer rate what they achieved for a spectrum is 79 bits per second per hertz. So you think of 3.5 gigahertz of this particular rate. It will be really faster network or the data transfer rates will be really fast. So you will be getting data in the GBps time. Now you are all getting in MBBS. Later you all will be in 5G. You will be getting download speed of GBps there. So here, this is an 8 cross 8 MIMO part. So where they use with this multiple USRPs are there, SDR hardware, software defined radio modules. So this is what the components where we'll be having to use with. I could say something as different cells regions where we are going to travel or shift from one network zone to the other network zone. So how we are going to operate. So these are the NI offerings for academics to do their research on millimeter waveform or part, or to work on an SDR related applications or RF related applications. So where they can start with basic frequency ranges of 10 megahertz to 6 gigahertz range where they can work with, or they completely want to work on something as a standalone applications they can work, or if they want to start something from 50 megahertz to 2.2 gigahertz if they want to work with, they can choose. So there are a wide variety of modules where they can go with. And the right side part, the millimeter transceiver system, is something as a what we could call it as a MTS, millimeter wave transceiver system, which is something as a test bed for testing your millimeter wave technology as a 5G test bed platform. You can implement in your college research lab, and you can work on your part. So this is our offerings in NA SDR academic kit contents, where we can give for a small 2x2 MIMO part, or where we can give a single channel RF module or multiple channel RF module, or a standalone RF modules where we could give over there. So we should have a computer in it, and it will monitor what are the applications are running in it. So these things you could easily go with this kind of hardware kits you can easily work with. And there are softwares by which we will be configuring them. Is NI offers two different softwares. One is LabVIEW as a basic version where you can start do your program and you can communicate with any of the NI modules, and you can program of your own logic. Or very specific for communication related, we have a communication design suite which comes with a predefined network framework architectures. For example, we have this 802.11 architectures we have, or we have this LTE architectures we have. So you can directly start do your research work from that architecture, and you can work on your MIMO parts or any other RF related activities. So as I was mentioning you about this MTS platform, so NI offers a millimeter wave solutions as well. So depends upon the frequency part, or depends upon the elements we could implement, and we can plan for our test systems there. And this one important thing which I want to share with you is this. I could say 5G trials are happening in India, where mostly in Delhi and surrounded areas. So it was a very long back information, but still, this informations are which shows us at least we are doing some operation related to this 5G related networks and who are there in it. In India, we have this ATAL service provider who are into this 5G network maximum, and they are doing it. and they are working with majorly with a Nokia team. So where they provide things and they are going ahead. See, basically, I want to split RF players into two category. One is service provider, other one is a infrastructure provider. If you see on my right side screen, on the top side, whatever I have, these are all service provider who are all network providers. So these are all US, UK, and Australia, Singapore. So different peoples who are there, China. So different companies there. AT&T is in US, Sprint is in US. So Dutch Telecom is in German, and Telstra is in Australia. Verizon is in Australia. Vodafone Group in England. SK Telecom is in South Korea. Singtel in Singapore. Orange in few places they have. Orange we have in Australia there. NTT Docomo is in Japan. LG U Plus, Korean Telecom, LG is are there in Korea. China mobiles we have. So these are all network providers in different countries. Similarly, in India we have Airtel, Jio. So we have this Vodafone Idea. So these are all the people who are the major players now. So the other hand, if you see the below one, these are all companies who provide infrastructure providers, which means these companies will give you a 5G network, but who will give you handsets or your routers or your gadgets for it? For example, if you could easily see that Netgear is there, ISS phones are there, HTC phones are there, LG mobiles are there, Sharp mobiles, or you could say other the Oppo is there, Vivo is there, Sony mobiles, and MI mobiles. So these are the people who provide infrastructure providers there. So these are all end users. We could call it as a end nodes in other way. So if you see there, excuse me, yeah. So in this, these people are getting to the end user node. Apart from it, there are other two key players are there. One is Ericsson and the other one is Nokia. So Ericsson and Nokia are the people who are the real players in this 5G market, who get into this who get this 5G network into reality, because Ericsson and Nokia are the people who come up with your antennas or your transponders or your reflectors, which is there in the tower station there, which is there in your base station. So unless until those devices are available, we can't have our end user nodes as a modules there. So Ericsson is collaborating with Qualcomm, and they are coming up with this end user devices which could be a 4.3 Gbps. So they test their own, and NI is collaborated with Nokia to come up with testing their standards and move on there. So now here one important thing is this Qualcomm is playing a really a very big role in 5G, because all these mobile phones are 5G supported. They will be having this Qualcomm Snapdragon 5G mobile processor chip, because whoever has this 5G network processing, these all people are going to have this particular Qualcomm Snapdragon 5G processor in it. That's why if you see there, all mobiles will be mentioning there, this is my processor there. So I earlier used to have this MediaTek Snapdragon 850, the other things were there. So now you all have this 5G processor. Now you could see all these mobile phones, they will say, yes, this mobile will support 5G, because they will be incorporated with these mobile phone processors, and they'll come up with that. And when get into this part, I think I'm done with this 5G related part of here. The major thing where we will be using this artificial intelligence is only the place of this IoT come into picture there. So as we are mentioning here, where the smart industries are there, because without wireless sensor network, or without this, I could say it as small cell based applications, we cannot get with this artificial intelligence do the real work there, because where exactly the algorithms are running, algorithms are running in a device where these machines are going to decide whom to send the package, whom to make it there. For example, in a public place, I could call it as a bus stand. So in a bus stand nearby, we have a tower. So a tower station has to give signals to every passenger there, but it depends upon whom to give more priority, whom to give more bandwidth. Because if I am using only my mobile phone for texting, or I am using my mobile phone only for making a call, I can be allocated with a lesser bandwidth. Whereas I am using a video call, or I'm making something as a uh, what I could say it is a WhatsApp chat with a video chat, or I could say something as a YouTube videos I play, or I attend a meeting. So then I require more bandwidth. So how exactly the cell phone tower or a small cell in a bus stand or a bus stop, who is going to decide whom to give the major network, so that they will be enjoying this service hassles free there. So where our artificial intelligence or the devices come into picture there. So now, if you see over there, how, because many places you would have seen every 5-6 kilometers now you all have these cell phone towers. Now the distance has now these distances will shrink a lot, because if you see over there, we have this wireless sensor network which started coming up on the third generation of wireless system itself. Because this wireless sensor network, whatever we are going to use, these are all available from a longer time, because many people would be working on this and they are all aware of it. These are the modules what we used to have. I could show you with this information so that it will help you out. Where we have this different products where we connect to it. So see, these modules you can directly connect to it. There will be a gateway, there will be end nodes. They are all wireless modules, so where you can connect sensors to it. It will be connected via ethernet. The gateway will be powered with a wall socket power. The end nodes are battery powered, so it will run for a minimum 2 years of time if we are not touching anything there, and on a standby part and in a normal operations there. So if you think that the data consumption or the energy consumptions are very very less in this, so I just get into this wireless standards there. So if you see in it, so which would be ideal for longer distances, obviously the cellular part. Very very short distance communication is your NFC, or I could say it as a Bluetooth. So this would be there. So there will be something as a mid-range products, which is our wireless devices, such as your router, or I could say it as your Zigbee. So these are the thing. See, very simple example. See, wherever we are, we can get connected with our cellular network, but our mobile phone and our Bluetooth headsets will operate at a very shorter distance, and our house Wi-Fi or our office Wi-Fi will connect to a particular distance. If you are there at the second floor, ground floor wireless will not reach to the second floor there, but it still support on the first floor. So this is the way we could clearly understand that distance is part of our devices there, wireless standards of devices. And where exactly this cellular comes is the data transfer packets of cellular networks are very very less. It will be in a very less data transfer rate, whereas our Wi-Fi or wireless things are more. So that's the reason in earlier also I was telling you about, if I am sitting in a bus stand or a bus stop making a normal voice call and I'm making a video call. So if you see the data transfer rate, where I need more is in a video call part I need more. So I need to have an algorithm which has to decide, an intelligent system should be there to decide and give me that particular bandwidth, where we calling as a beamforming. So this beamforming is the one which is going to literally, I could say it as a turning your antenna towards your mobile phone so that it will reach you. So this wireless sensor network in N9, it uses the Zigbee protocol, IEEE 802.15.4. So the data transfer rate is little less, but it will have a good coverage, a decent coverage, and it can work. So if you see in here, so Zigbee will work for a battery life which is a longer days, and your mobile phone with Wi-Fi enabled, your battery will drain fast. So this is the difference there. Simple comparisons there. And if you see there, every 30 meter you need to have a Wi-Fi coverage, and if you have your Zigbee over there, you could use it for a longer coverage over there. So for example, I want to monitor the structural health of a bridge. So what I could do is I cannot have a Wi-Fi router over there, which if a bridge is of 100 meter long, every 30 meter I need to have my I could say as something as my Wi-Fi repeaters I need to use. Whereas if I use a Zigbee part over there, I could have my gateway at the center of a bridge. At the two end corners, if I use my repeaters or my end nodes, I could have this entire bridge covered with my Zigbee protocols there. This wireless sensor network. So this is a good way, and which will operate for continuous 2 years or 3 years, where every 1 hour I need to collect some data. So every 5 hours I need to collect the data of a vibration or an acceleration or load involved in it. So these things I could easily measure with them. So these are the parts how it is. So here in 802 we will have a gateway, router or end node. The one good thing what we have it is our end nodes will act as a router itself. So end nodes will act as a repeater. Here if you see I have a computer which is connected to a gateway. In a gateway I am connected to 3 different end nodes. These end nodes are directly sending data to the gateway, and they will not communicate to each other. So now I configure this as a repeater mode or a router mode. So what we could do it is I can make this as a gateway from a two routers. Each router will communicate to every individual nodes over there. Then I can communicate to all nodes via this router, and I can get the connectivity part very easily. So this is what I was mentioning. In the center of a bridge I can keep a gateway. From a gateway I can communicate to my system. Or I could say at the starting of a bridge I will have an end node. At the mid of the bridge I will have a router. At the other end of a bridge I will have my gateway, where I connected to the data center to acquire all my data, and I'll work with this. So will be the one good thing, and this 300 meter is also area of coverage on the line of sight space. So this is very important, because when you have some diffractions, or when you have some disturbances with a clustered area or trees or a lot of buildings over there, then you need to go for a multiple routers option. So you have to have your own topologies to be built up with and do over there. So the data transfer rate will be a little slow, the update time for these modules. So every 60 seconds, the data samples what it will take. So 60 samples per minute. So every second, one sample it will acquire and it will show you. For thermocouple, it will be every 2 seconds it will acquire data and move on, because the update times depends upon the distance where it will be. It is a very shorter distance, so the data will transfer faster. When the distance is too far, the data transfer delay will be little bit will be there in it. Then, so maximum we can go for one router. We can go for 8 end nodes per gateway we could use. So if you see maximum 36 end nodes or routers, we could go with that. So here, one single system you can connect to 8 nodes, and you can connect and you can easily go up with, and easily you can plan, and multiple number of devices you can use with. So these things are higher channel configurations would be useful for our factory operations part, because in this factory operations, if you see, there will be multiple units will be there in it. So where I need to move on from the production unit to packaging unit, or from a packaging unit, it should be given to the shipping part, or the where the shipments are handled, whether the tracking of these packages, so labeling elements. So when starting of the raw material to the end of the labeling part and packaging things, so there will be a very big area of coverage will be there where everybody in a place has to monitor all these actions. So in that case, we could go with higher channel configuration part, and it will give you a different options where you can go with a star topology or a cluster tree. So one will be a gateway, the other or will be your routers. The few things will be your end nodes. You could easily go ahead, and different types of options you can go in. And this is a very good reliable connections when compared to your cellular and Wi-Fi, because your cellular and Wi-Fi will not reach out to a larger distance with a good transfer rate. See, cellular can reach a larger distance, but the data transfer rate will be less. Wi-Fi will have a very high data transfer rate, but the area of coverage will be less. So WSN will be somewhere in the mid range where it will have a quite decent area of coverage with a minimum of data transfer 250 kilobits also you could transfer, and you can get it for a longer lifespan over there. The duration of operation will be more than 2 years or 2.5 years over there. It is a battery operator, or if you want to have a wall socket operator also, you could have the wall socket operator there. And these are the different options where you could go with. So one, you can go with a normal WSN based, or different companies model makes also enable support, and you can work. And PXI RF related options also will help you to go with different wireless test and modules over there in it. So the benefits of going for WSN is reduced cost, and you can increase your efficiency part, and you can monitor anywhere because your WSNs will act as your small cells, because everywhere you are, whenever you want to get connected with internet, or whenever you want these modules to be connected, so you could easily connect it and you can monitor over there. So this is one good thing, and since it is all connected there, so your response time or your response elements would be very faster, so that there won't be any downtime, or very negligible downtime will be there. So whenever there is some errors or things, it should be immediately reported, and it could be rectified as well. So do you see over there, up to 3-year lifetime, this end nodes can work with 4 AA batteries there. You can easily go with that. It's a really a good thing. And this is how, where this WSN will get into it. See, now if you see there, when it got to the World Wide Web or this wireless enabled objects is, so this is the place our cellular networks come into picture. This cellular network where we are speaking about this 5G, but to enable that 5G or to work out with different industry of things, so we will be having this Ethernet based connected real-time computers, and where we'll have a programmable units, where we'll have our database server to get connected with the real-time sensors informations. We'll be going with these such modules for wireless related operations. So this is a place where we have this wireless sensor network options, and this is the specification of a gateway, so which works in the 2.4 gigahertz 802.15.4 radio, which is a ZigBee based operations there. So which works in a rate of 0 to 90, 9 to 30 volt of DC power input, and it can easily go up to a 300-meter coverage in an outdoor of a line of sight. That is more important there. So these modules are industrial standard or industrial cadre modules there, which could easily withstand of high shock, vibration, or operating temperatures there, because these modules consecutively they won awards for the industrial standard DAC modules over there. So this has a real-time module in it, a gateway, real-time gateway it is, and other things are end nodes there. So where these end nodes are programmable, which could be used for analog input or thermocouple or voltage input, or I could say it as your RS-232 or 485 communication modules also. If you want, we can make use of it. So these modules, different types of modules we have over there. So this is something where it will come with an enclosure. If you want to deploy things at a very remote place, then we can directly connect it and we can read this values over there. In terms of very remote place, you can go with your additional accessories with that. So again, so there will be a software involved which will be a LabVIEW one. So through LabVIEW you can configure them and program it. After program you can detach from your PC, and your gateway will still support and continue over there and monitor, and it will act based on your the code what you have given in your software part to program WSM. So this is the way how you will be do programming, and there are few methods or few architectures. So how they are trying to use it. So where are the places this WSN can be implemented is, so one is for your environmental monitoring or your indoor monitoring or bridge monitoring or mission condition monitoring. So different places where we could use with that and where we can go ahead. So this is one. Uh, so for which applications we could use for that purpose, we can choose our module, whether we need to go for a wireless DAC system or a WSN based DAC system. So Zigbee based or Wi-Fi based there. So do you have any queries? I think almost I'm done. So this is for the bridge health monitoring and health inspection system over there. So where they can have their router or where they can have their uh, wireless end node for it. Because if you see this part, whatever we have here, so this is a wireless node here, which is attached to it to understand the crack or the load, what it is over there, the stress or force monitoring there. So they have used with this. So do you have any queries?
So myself, Madhusudan.
I'm done with my session.
Can you able to listen, sir? A.Manimaran, sir.
Yes, I can
Yes,
hear you.
myself, Madhusudan, talking from Karnataka, JNN College of Engineering.
Which college, sir?
JNN, Jawaharlal Nehru New College of Engineering, Karnataka, Shumoga.
Okay, sir. Okay, sir.
Okay, regarding how you are supporting academic institution in your instruments wise, sir, do you give any concessions or like that? If you have any, we are coming under Vishweshwara Technical University.
Yes, sir.
We are planning for the autonomous and all those things. If
Yeah.
we are planning in our syllabus, your instruments like basic experiments to show the 5G, how the frequency will work, and all those things while setting up our syllabus and all those things. How
Yes, sir.
you is going to support for the academic institution in terms of your instruments or in terms of budget and all those things, sir?
Sir, frankly speaking, now if you see under VTU syllabus,
Yes.
and if you see for Anna University syllabus, so for both the major technical universities, what we have in Anna University syllabus, it is there in a 7 semester. So where they have this advanced communications laboratory, whichever colleges falls under Anna University, they supposed to have this infrastructure to teach communication based related experiments they have, sir. Similarly, for VTU, for communications lab, they have this BPSK or different differential BPSK models
Yes, sir.
related
We are handling right now
experiments
for
are
the
available in
seventh sem
communications lab.
students. We are handing light round for 7th sem students, all those things.
Yes, sir. Yes, it is
Yes,
there. It is
yes.
already there into the syllabus. So what we are supporting is we are supporting with the LabVIEW related packages to them. So we are enabling their faculties with the programs so that they will be continuing with the labs there. This
Okay,
is with respect to the academic syllabus content.
okay, sir.
Apart from it, there is an internship in VTU is there.
Okay, sir.
So where they can do it on the 6th semester or 7th sem.
Okay. Can you please share the team they are handling supporting for the ATM academics
Sure, sir.
related things,
Sure, sure.
mail ID or
What I'll
like
do
that? If
here
you are
is,
there, I will going to
uh,
communicate with them, that people.
so what I'll do here is, I share my details over there in a chat box,
Please, sir. Thank you.
where you can contact me related to your academic related activities.
Thank you so much, sir. Email ID, official email ID. Yeah.
Yes, I
Thank you.
shared my name, my mobile number, my email ID to you so that you
Definitely.
can reach out to me so that we can discuss what would be suitable for the budget you have. Based on the budget, we can have different types of modules we have, sir.
Thank
So
you
there are
for
modules which will be there for, I could say it is for 7 lakh, 8 lakh, 10 lakh also it is there. There are in 60, 80,000 to 1 lakh also we have modules. So based on the budget availability, we could finalize it.
Okay, sir. My all queries are fulfilled. Thank you so much, sir. It was a
Thank you,
nice
sir. Thank
session
you very
indeed.
much.
Indeed, you have covered everything very systematically. What are the things in your industry or a company what you are doing, and it was very systematic. And even for the lunchtime also, we are able to you grabbed our attention, and we are active in your
Thank you,
session.
sir. Thank you very much, sir.
Thank you
It's
so much.
nice to hear from you.
Thank you.
And to Kanmani ma'am, there is a query here. Sir, what simulator are you using for your massive MIMO testbed? Ma'am, the simulator is nothing. Actually, it is a hardware, real hardware. NI, FPGA based flex rios are there. NI PXI modules are there. NI USRP hardwares are there. There is no simulator. The hardware are generating real signals, which is all these NI DAC modules, RF modules where we have. So where we have these IO modulators, where we have this where VST or RF signal analyzer, RF signal generators where we have in it. So that kind of modules which we used it. And the software obviously used here is LabVIEW and communication design suite. Hope I answered Kanmani ma'am's query. Is she there? Ma'am, are you there? Okay, okay, thank you, thank you.
Thank you, sir. Any other queries from the participants? Okay. Thank you, sir. Thanks for your wonderful presentation. I would like to thank our resource person, Mr. A.Manimaran, Manager,
Sir,
AI Solutions, Bengaluru.
sir, is it audible to you, sir?
Yes, ma'am, I
Yes,
can
ma'am.
hear you, ma'am.
Yeah, I'm Kanmani,
Yes, ma'am.
right from Jerusalem College of Engineering. Sir, are you allowing the students to do the project in massive MIMO, sir? ME
Massive
student,
MIMO,
ME student.
ma'am, ME student, massive MIMO, how many antennas you are planning, ma'am? Because based on that only we need to decide. Because modules will be more.
Currently, we are working with the 100 antennas, sir. Simulation,
Okay.
simulation we are
Simulation.
doing
Okay.
in
Okay.
MATLAB. In MATLAB, we are doing it.
Okay. Okay.
But real environment we have not entered into that, and channel estimation also we are working over that.
Okay.
Is it possible to allow the students to do the project over there, sir?
Ma'am, we are working on LabVIEW. We are working on NI modules.
Yeah.
A few MATLAB scripts also we are taking it for our algorithms, but not totally into MATLAB. So we are allowing in the sense, since we are not, don't have that much expertise in MATLAB, I'm afraid we are not doing it.
So, in the problem in MATLAB is that channel estimation we really find very difficult, sir. Oh, we are
Because
planning to. Oh,
there will be different algorithms you need to have, different modules, toolkits you need to use with.
hmm. So, is there any chance of proceeding our project over there, sir?
Ma'am, here if we are doing it with LabVIEW, probably we could help you out. I told you, right, we don't have that much expertise in MATLAB.
Okay, okay. Yeah.
So I'm not sure how much we could help you in this.
Okay, sir.
If it is in LabVIEW,
I'll
probably
mail
we
to
could help
you in
you out.
person.
Hello?
Hello.
Yes, ma'am. You said something last one, I didn't get you.
I'll check with the students whether they can do it in LabVIEW,
Okay.
and then I
Ma'am,
can contact you, sir.
ma'am, in general bottom line, or I could say something is very very uh, top line, I could say as whether you use LabVIEW or whether you use MATLAB or whether you use Python or any other tool,
Hmm.
the algorithms whatever you develop could be developed or it could be used in um, any toolkit, ma'am. But only
Oh,
thing is how much time you spend in the tool to get master in it.
oh, okay.
So there is another faculty who asked for QualNet simulator. So QualNet simulator, no ma'am, we are not working on this QualNet simulators. I think this is on completely on this antenna mapping, right? So this is for this network coverage area mapping part, I think so. This QualNet simulator, if I'm not wrong.
Hello, sir. Hello.
Yes, sir.
Good afternoon, sir.
Good afternoon.
Sir, your presentation is good, sir.
Thank you.
Sir, how you calculate channel estimation using this NI USRB kit? I mean, because of everywhere in MATLAB view, we can use some channel parameters. I mean, that is the matrix we supply to get the simulation. But in real time, when we use USRB, how you get that channel parameter? Because you are
Sir,
using.
what algorithm you are using it?
Normally, whatever the experiments we do, channel matrix to get the output when you give the input. For the practical point of view, if you use USRBs, how you get that channel matrix? Channel.
Sir, there are different ways you could go with for MIMO. You could go with
For
OFDS.
single antenna, sir, for single antenna.
For single antenna, if you are going for this channel estimation, basically you will be looking for this bit error rate concepts only you will do. So how much there will be in errors in it. So for single transmit and reception.
Mm-hmm.
Hello.
Oh yes, sir. Yes.
So when you go for this channel estimation, that would be when you go for multiple antennas, then you need to go
I'm
for this
asking.
OFDM or
I'm asking.
different.
Sir, I am asking the procedure. Suppose how you, if we have the USRP kit means, how you get that channel estimation?
See, basically you need to code with that. So either you can use
I'm,
LabVIEW or you could use this.
In a LabVIEW tool, we get a channel parameter. Huh?
You need to program that. So that's what I'm asking. Which
Oh.
algorithm you are using? The same algorithm you can use it in LabVIEW and you can achieve it.
For
Because in place, I could say it in a simple way. In place, whatever you're using there as a up converter and down converter, USAP is going to work. So
What I am asking is, suppose if you study theory means we say it is a channel matrix such like that. Okay, we in a channel matrix we have the values of that means the phase and amplitude values that we consider as a channel values. And for a simple calculation, if I multiplied some input, then I get what is the output. What we do in theoretical point of view. In a practical point of view, if because of you are having the kits and you are doing experiments with it now, so I am asking what is the procedure to find out how you find that channel parameter values.
So there will be algorithms you need to develop with that. So there are codes for it. So I don't think so. I could share it here. Probably you can reach us separately. We could help you out, sir.
பொறுமையா பண்ணுங்க.
Hello?
Yes, sir. Yes, sir.
So you could reach me separately, sir. We'll discuss on it.
Okay, sir. Okay.
Yeah.
Okay, sir. Thanks.
Yeah.
Hello, Surya ma'am, do you have any queries? Any other queries from the participant side? Okay. Thank you, sir. Thank you for your wonderful presentation. The session was extremely informative for all the participants, as well as you have cleared all the doubts and you have given a wonderful session with demo also. And it will be more helpful for the persons, those who are doing their research in the respective domain, especially in the wireless networks and sensors domain with respect to IoT. Thank you for your presence and your valuable information to our participants, sir.
Thank you, ma'am. Thank you very much. Ma'am, one small request, ma'am.
Please, sir.
Can you please share the list of participants, ma'am?
Yes, sir. I will share to your mail ID, sir.
Sure, ma'am. Sure. Thanks. Thank you, ma'am. Thank you very much.
Thank you, sir.
Yeah. Thanks, everyone. Be safe during this COVID times. And I really appreciate your presence over this program. And I'm very much thankful to the organizers. Thanks for arranging it and thanks for having me here. Thank you, ma'am. I'll take a leave then.
Okay. Thank you so much, sir. It was a nice session.
Thank you, sir. Thank you very much.
Dear participants, we have given a feedback link in the chat box. Kindly fill up the feedback form for the attendance. After filling the feedback form, you can leave. Thank you very much for your patient listening for all the 3 sessions today. Tomorrow, forenoon session will join exactly by 10 a.m. Session is going to be handled by Dr. Sibiraj B. Pillai from IIT Bombay. And the title for tomorrow's session 10 is Understanding MIMO Using Software Modules.
Excuse me, madam. Ponlata, madam.
Yes, Madhusudan sir, please.
Thank you so much, madam, because of you considered my request and shared the last session. Thank you so much.
Thank you, sir. With pleasure.